Hi, last time I told you that you can get expression data if you go to NCBI GEO website. So here in NCBI GEO you can type whatever you're looking for and get the results. When you get them, you have to pay attention to the study type and make sure that you have expression profiling by array. And you have to click on expression profiling by how throughput sequencing. Those two will allow you to see all the gene expression data, whether they are done with microarrays or with RNA sequencing, either bulk or single cell, doesn't matter. Then obviously you say show. In this corner you can select which organism you're interested in, for instance mouse. But we will be working only with one particular data set, this one which we selected before. We will first run GEO2R, and we already selected these groups before, old and young. And then we will work on the generated R script, say analyze. The results table is back and all the figures. Now we pay attention to this plot, and the trick is that whereas computer cannot see the figure, you can see the figure, and it can save you some lines in the script. So when this scale is small and the boxes are not exactly identical, it means that data are already log transformed and not yet normalized. Of course, you can rely on the automatic detection like it is now. And in this case, we know that normalization is not done, at least quantile normalization, so we say yes. Annotation, there is no choice here, as you can see, otherwise it would be a little bit shorter script. And we have only two groups, so whether you click on it or not doesn't matter much. In more complicated cases it does. This FDR correction is okay. Reanalyze. So let's go to R script, copy it, and go to the RStudio with the copied script. In RStudio you say new R script, then you paste it, and then you save it as, so you give something like first name, last name, GEO2R, save. And now we can go through this script and check what can stay as it was and what can be changed and simplified. Remember that this is a algorithm generated script. It's written in such a way that it can be used universally for all variety of data sets. However, when you select only one data set out of many, of course you can apply some particular simplifications and modifications specific for this particular data set. It begins as usual. It's always nice to give a comments where it's from and what it is. Then you load the libraries. Everybody agrees with this. So for bioconductor packages you have to install Bioc Manager first, and with Bioc Manager you install GeoQuery, and then you install GeoQuery yourself and Lima. And when you have a so small number of samples, You do not really need UMAP, believe me. It is needed only if number of samples is, let's say, approaching 100 and more, then UMAP will be helpful. If it is a handful of samples, there is no point of using it. A lemma has own dimensionality reduction plot, which you can use instead. So then first lines are as is, because you simply import data from the sites indicated in CBI GEO. It sounds gibberish, but you better follow it. And then this line is also needed. But from here you will make modifications. What is actually happening here is the script will mark the first 4 samples, then skip another 4, then take the next 3 and skip another 3, and then all the samples which are not used will be removed out of here, and this is not good. But this is against the suggestions given by authors of lemma package, who never recommend to remove samples even if you don't use them, because A, you can change your mind and use them, and B, because the whole business is made in such a way that more samples is better for analysis and less samples is worse. And therefore, do not exclude samples. So this thing can be removed. Now, this part, it is the way how the script figures out whether data are log transformed or not. It relies on quantile values, and all these logical constructions are about whether the scale is big or small. But you simply can look at the scales by yourself and figure out whether they are log transformed or not. To check it, you simply type boxplot XPRS gset. Look how they refer to the expression data XPRS gset. So you do the same. You type it yourself, run, and then you see the scale is small, and the boxes are not exactly equal, and therefore you can say, no, I don't want a log transformation, and delete this part as well. Then the next step is whether we have to normalize or not. Yes, you still need a normalization, and it is the standard function in lemma, normalize between arrays. And if you type what is this, the default is a quantile for 2-color data objects or quantile for single channel objects. We have a single channel object in this particular case, so don't worry, it will be quantile normalization. Here, because we deleted a chunk of the lines on the top, this will not work. We have to define the groups what we compare. For this, we have to rewrite the whole business differently. What you have to do, you have to go into the description of gset phenodata data and title, which is next to GeoAccession, where you will find these descriptors for each column, what is what. This, as soon as you click on the title, this thing appears, which you copy and paste into a script and say samples are like this. And then if you go to samples, it gives you a good description what is what. Now I prefer a standard trick with the splitting sample identifiers by underscore. And then you write this pretty tricky complicated line where you at the core is a string split function of the samples, which are names with underscores. These are samples. So then you declare it as data frame and then as transpose data frame. And this is what you get. So it's almost good. 3 columns, while type, age, batch, and then the row names are spoiled. You have to restore them again. So we have to write a few more things. Row names, pay attention to the capital and so now we recovered row names. They correspond very well to what you have. And column names will be cell type, age, and batch. Call names, samples, cell type, or simply cells, age, batch. Now we are ready for the model matrix, which will be you do it by age, for instance, or by cells, or you can do it by age and cells. Our original intention was age, fine, and here is not gset but samples. Oh, yeah, there is still one more line. Samples should be data frame. Every time you do transpose, data frame disappears and matrix appears. Now it is. Then you don't need this line. It still belongs to old script. You can keep this line in place. It skips missing values, and then you run the feed. Then this can be also simplified. You simply ask what for a feed we have, and it says age old, age young are compared, and therefore instead of pasting something, you simply say contrast matrix is may contrast are age old minus age young. And then contrast fit then fit to bias. At this stage you finally get p-values. After p-values you sort the resulting table, but number should be infinity, because you don't know where it ends. It may be longer than 250 or shorter. Here you have a freedom to select the columns, so you can ask what TT is. The ideal is call names TT. So ID, entry gene ID, description, log FC, average expression, T value, P value, adjusted P value, and B value. Up to you. What is missing here is that you still have to get your list of differentially expressed data. You don't need a full table. Why you need it? For this you write this line: tops are subset of TT with adjusted p-value less than 5%. That's a standard. And these are your tops. What is missing here, better not do it, is that the real gene names, where to get them, I will tell you in the next video, because it is a little bit longish story again. But the resulting table is ready. You have your tops of 822 genes, and here instead of full table you better save tops table. This is what you're really interested in. To summarize, these are the changes you can do in the script to improve its quality and clarity for yourself. I do not discuss visual part. At the end of the script it's only visual, and I do not discuss an issue of gene names, which is again another matter for another video.